Hey guys, hope you did well on your quiz today. This is the next thing that we'll be studying is section 5.5. 5.4 just has more identities in it that we will go back and grab if we need them, but I don't think it's worth it to go through the whole section and do more of the same type of problems just with different formulas. So we're going to go to 5.5, which is solving equations that have trig functions in them. And we're going to do a series of these problems for you, starting with number 12, which is on page 703. And we're going to continue all the way up to number 62, the odd ones. So this will be part 1 of 5.5. And if you're good in algebra and solving equations, you should be good with this too. So let's just get right into it. And we'll be relying on our unit circle a whole lot too. So let's see. If we're given this equation, really what this is asking us, for what angle is the cosine equal to square root of 3 over 2? And we want all the answers that are in the first 2 pi. So if we look at our unit circle here, we look for all the answers that have in the x position a square root of 3 over 2, and we have a pi over 6. And we go over there and they're negatives though. But over here, the x value is still positive at 11 pi over 6, so we get this. The back of the book will give this kind of answer. It'll say plus 2 pi n, or 2n pi. This says pi over 6 plus every time you go around that circle 2 pi times, you're going to get that same answer. Whether n is you go around 5 times, or 10 times, or 2 times. So this part won't be on your quiz. I just want within the first 360 degrees or 2 pi, how many times did the cosine hit square root of 3 over 2? And you might be saying, well, we were doing stuff like that already, but now they're going to add things to this equation. They're multiplying the sine by 2 and adding the square root of 3 to it. It equals 0. So what I want to do is I want to solve for the trig function in the equation. And then ask myself, again, this is the notation for what angle is the sine equal to the square root of 3 over 2? And again, you take your unit circle and you look it up and you find out it occurs in 2 places. I would suggest that you do these over again. If you want to pause the video now, that would be a good idea. Number 26, same kind of problem, except that it wants the value of x and the angle is 2 times x. So what we do sometimes is use what we call a dummy variable, and this happens in calculus a lot. We'll say let u equal 2x, and let's solve this equation instead, and then we'll figure out what x is later. So if we do this, we found out that our answers came out to what we had before in the top one. But now this time, u is 2x, and we want x. So if u is 2x, and we got a pi over 6 for an answer, we say, well, pi over 6 now equals 2x, because that's what u equaled. And then we solve for this by dividing both sides by 2, and we get a pi over 12. So in other words, we're multiplying both sides by 1/2, right, to get this pi over 12. We would do the same thing with 11 pi over 6, and we get 11 pi over 12. Think through that one as well. If you want to pause the video now, it would be a good time to do that and try those again. The next one I chose was number 36. On number 36, we have, except for they had a 2x last time, they have a 3 over 2 theta, and it equals a square root of 3, but yet it's a cotangent. So I'm asking myself, cotangent is x over y. If x over y, what angles, where does that happen where the x divided by the y is the square root of 3, or negative square root of 3? Well, at pi over 6, the x is, check it out, at pi over 6, the x is square root of 3 over 2, and the y is 1/2. If I divide those, I'm getting square root of 3. I just don't get negative square root of 3, so I'm on the right track. But if I look in quadrant 2 on my unit circle, in quadrant 2, I get the negative square root of 3 over 1/2, and I get 5/6 pi. And at 5/6 pi, if I divide these, that's where I'm getting my negative square root of 3, at 5/6 pi. If you notice, take a look on your unit circle, it also happens down in the 3rd quadrant. This would be quadrant 3, where the square root of 3 over 2 is the positive one, the half is negative, and we still get this negative square root of 3 here. However, if we let u equal this 3 theta over 2, and we just found out that u was 5/6 pi, now let 3 theta over 2, which was u, equal 5/6 pi. Multiply both sides by the reciprocal, and we would get 5/9 pi for theta. Do the same thing for 11 pi over 6, and we'll get 11/9 pi. Try this one. Pause the video and try that one all over again. So, the next problem we're going to do is number 44, which look a little bit challenging. Now, all these in this section are what they call quadratic trig functions, trig equations. So this one says this is a 6. But this is the ugly part of the equation, is the sign. So I'm going to let u equal sine of x and replace sine of x with a u. And now this becomes like a 9th grade problem. I set it equal to 0. I divide it through by a 2, and I got this. And then what I'm going to do is I'm going to factor this, u and u. 3 splits up to 3 and 1, negative and positive, so I get the negative 2u. And then I find out that setting them both equal to 0, I get u is negative 1 and u is a 3. If u is negative 1, and we let sine equal u, so that must mean that the sine of x equals negative 1 because sine was equal to u. And I look on my unit circle and I say to myself, at what point on this unit circle is the y value equal to negative 1? And it happens down here at 3 over 2 pi. So 3 over 2 pi is one of my answers. The other answer could be is that the sine x, which is u, equals a 3. Well, sine x can never equal a 3 because sine is opposite over hypotenuse. And opposite over hypotenuse could never be a 3 over 1 because the opposite could never be bigger than the hypotenuse, which is the largest side in any triangle. That was a test question way back early, maybe even the first chapter that we tested in. So this one is not a null set or a non-existent answer, so our answer is a 3 pi over 2. The next one, I meant to do 54, but I did 53 by accident, so I'll give you the answers to 54. But this is our equation, and it looks really complicated, but in fact, they already factored it for us. So what I'm going to do is I'm going to set each factor equal to 0, and I'm going to solve. And if tangent of x equals 1, that notation, remember from the inverses, the arctangent of 1, says for what angle is the tangent equal to 1? And tangent is the y over the x, right? So for what angle is the y and the x the same so that it comes out to be 1? Now if we look here, we notice that at 45 degrees, or pi over 4, we get square root of 2 over 2 over square root of 2 over 2. The x and the y are the same, so the tangent is equal to 1. So at that place, the tangent equals 1, and that also happens down here at 5/4 pi. This one says, for what angle is the cosine equal to negative 1? Well, the cosine is equal to negative 1. Cosine being an x value, it equals negative 1 over here at pi, so our answer is pi. So go through these again. The answer to number 54 is right here, if you need it. Try these, and this will be part 1 to this section 5.5 in your homework. Good luck.